Good morning, everybody, and welcome to the 2023 TIDC New England Railroad Symposium. My name is Bill Davids, and I'll be filling in for Dr. Habib Dagar, who unfortunately could not be with us today. I'd like to start by just saying how excited I am to be here. We're all aware that transportation infrastructure industries face unprecedented challenges, opportunities as well, but challenges, and none more so than railroads. And this symposium is dedicated to addressing challenges such as funding, operations, safety, maintenance, and efficiency of our rail infrastructure. Now, in the interest of full disclosure, I have to say that I have no expertise in railroads. However, my father and his brother, my uncle, spent their entire careers in the railroad industry as engineers. Not the type of engineers that drive locomotives, but the type of engineers that work on railroad infrastructure. So I have a soft spot for railroads, even though I don't understand much about them. And every time I have to stop for a train at an at-grade crossing, I don't fidget, but I count cars and I look what's coming and coming down the track. And in rural Maine, that's often tanker cars full of propane, coming out of Canada. Cars full of clay slurry headed to our paper mills, lumber products, and I'm always reminded by how important rail infrastructure is to this country's economy, and in the case of passenger rail, to the traveling public. So I think today's symposium is going to have something in it for all of you of value. We've got a great keynote speaker lined up, David Fink, the president of Pan Am. We've got 3 sessions. One is going to bring in experts from across the country to give a national perspective on the rail industry. Session 2 will introduce you to some of the TIDC research that's taking place right now. And the 3rd session will give the regional New England perspective on the rail industry. Now, by way of background, the TIDC is part of the Advanced Structures and Composites Center. And that's the largest university-based research center in the state of Maine. It's been in existence for quite some time now. We're going on 27 years, 28 years. It's supported thousands of students, employs several hundred people. It's a 100,000 square foot lab that allows us to take concepts all the way from design to manufacturing to testing to implementation. It's an IAS accredited lab, which is fairly unusual at a university. And in addition to focusing on basic research, we really do have a strong ethos about bringing research into practice, and that's reflected in the over 100 patents that have been developed at the center, 10 plus spin-off companies. So it's really a wonderful and unique facility, and if any of you have a chance to come up here and visit it, I would really recommend it. Now, the main theme within the ASCC is green energy and materials, and there are 8 research thrusts that support that. And right at the top of the list here, thrust number 1 is civil infrastructure durability. And that is very important to the Transportation Infrastructure Durability Center. But playing into that, of course, you'll see examples of large-scale additive manufacturing and how that supports our TIDC objective is advanced structural concepts, structural thermoplastics, structural testing. So many of these research thrusts are really relevant to what we're doing today. And the Advanced Structures and Composites Center has over 500 research sponsors and clients from around the world. Civil infrastructure durability has long been a focus area of the ASCC, and we're really looking to develop novel structural systems and hybrid, composite, enhanced thermoplastic materials they last longer, they're more durable, they're faster to construct and erect, and you'll see some examples of that in a few minutes. And this really led us to pursue the Transportation Infrastructure Durability Center, and in particular going after USDOT funding for the Region 1 New England Transportation Center. And the TIDC is a consortium of multiple universities. And I want to point out that this is not just the University of Maine. Without our partners, we would not exist. And you see them listed down here at the bottom. We've got UConn, UMass Lowell, UVM, URI, Western New England. We have at least one university from every state in New England, with the exception of New Hampshire, and we're hoping to change that actually in the future. And our research is guided by DOTs and industry. Every project has a technical champion. We focus on real research needs. We've supported over 250 students, funded 75 projects, 53 of which are active. Nearly 100 faculty and staff researchers across the 6 partner institutions have been part of this. We have 4 major research thrusts: monitoring and assessment, new materials, new systems, and connectivity for enhanced asset and performance management. And you'll see examples from research from some of these thrust areas in a few minutes. A backdrop to this that is not unimportant is the Senate passing the $1.2 trillion infrastructure bill. And $110 billion is in there for roads and bridges, and that will help support university research as well as actually paying for construction and repair. But there's also $66 billion in that bill for railroads, and that will include upgrades and maintenance to our passenger rail system and our freight rail safety. And I think we all here believe that we know how important this is and how critical it is to maintain this rail infrastructure, and actually not just maintain it but make it better, because it's extremely important to the economy of this country, and it's exceptionally efficient as well. Our advisory board is something that really sets us apart among other university transportation centers. We have an advisory board that's chaired by Dale Peabody from the Maine DOT. He's a great leader, and he does a wonderful job of chairing this group. We have a representative from each one of the New England state DOTs or transportation agencies on there as well. And those are the folks that are looking over our shoulder, making sure that the work we do is relevant and it's addressing the problems, the transportation-related problems that they're concerned with. The TIDC also has a management team. The director, Habib Dagar, Jim Bryce is the program manager, and we have other staff members and faculty representatives from each one of our partner institutions. So collectively, we also help set the vision for the TIDC and keep it moving forward. I want to give you some examples of research projects that we've successfully conducted so far in our relatively short 5 years that we've actually been in existence. One is the development of the G-beam, a composite bridge girder. It's a tub girder. It's corrosion resistant, made of E-glass and FRP composite, designed to last 100 years with little to no maintenance. Developed at UMaine and patented at UMaine. It's got some great features. It weighs as little as 1/3 that of a steel girder. One flatbed truck can transport enough girders for multiple 60, 70-foot long bridges. It's got a really unique way of connecting the concrete deck to the beams that allows for future deck replacement with minimal destructive work. And we've been partnering with UMass Lowell recently to conduct live load testing on the first such bridge built of this type, the Gristmill Bridge. The picture on the lower right is really interesting. That is showing you 8 girders bound for Florida that were built by AIT Bridges here in Brewer, Maine, designed and built. This is a good example of how we bring research to practice. Advanced Infrastructure Technologies is a spin-off company of the University of Maine. They're located about 12 miles from the University of Maine, and they have licensed this technology, and to date 4 bridges have been built with this in a very short period of time, with more to come. And those bridges were light enough that it was cost effective to make them in Maine and bring them all down to Fort Myers, Florida on one truck. At this point, I'd like to show a video of the erection of the girders at the Hamden Gristmill Bridge. This is the first bridge built with the G-beam girders. We had developed that at the University of Maine, and this is a really good example of research into practice. The Maine State DOT saw that we had developed these girders. We'd run some tests. We demonstrated their capacity, and it was really a show of faith. They said, "Okay, we're going to put these on U.S. Route 1A just south of Bangor, Maine." Notice here you've got 2 girders being lifted into place with a single crane, one pick. That's only possible because the girders are so lightweight. The other thing to notice is they're connected together by utility hangers, and pre-attached to the girders are a sewer pipe and a water pipe. And so this really expedited the connection to utilities. The crew did not have to come in there in the bare girders and do overhead work to attach most of the pipe. Ultimately, this bridge has 5 girders. 4 of them were lifted and placed in pairs, and 1 was placed as a single girder. Now let's talk a bit about our research thrust areas. Under Thrust Area 1, monitoring and assessment for enhanced life is an area that we've been working in quite a bit. This is a project that has jointly involved the University of Maine and UMass Lowell. We're very interested in assessing the condition of our existing infrastructure, and seeing if we can make it last longer, seeing if we can get it to stay out there without being repaired or retrofitted. That can save the DOTs a lot of money, and we've been successful in that area. At UMass Lowell, Dr. Suyang Yu has been leading some really interesting research on electromagnetic detection and identification of concrete cracking in highway bridges. We've all seen plenty of old concrete bridges out there with corroding rebar and spalling concrete. Detecting cracking is really the first step towards determining whether or not you're going to have a problem, whether or not it's going to progress, whether you're going to get corrosion of that rebar. Suyang's been taking a multi-pronged approach that incorporates both the development of really novel technologies, laboratory testing, and then in situ, in the field work to determine its effectiveness at full scale as well. Dr. Vivian Wong at UMass Lowell has been working on this area, in this area as well. Distributed fiber optic sensing systems for bridge monitoring. This is a great picture of a rusty old bridge. I always ask my students, when you drive around, do you look at rusty old bridges? And you know, these rusty old bridges, we need to worry about the kind of shape they're in and how much load they can carry. And Vivian's been doing some really interesting work on developing fiber optic systems for monitoring these, increasing the potential for being able to remotely assess condition, make decisions in real time about what needs to be done to a particular structure, detecting damage, and especially if it's severe and needs immediate attention. Research Thrust Area 2, New Materials for Longevity and Constructability. 16 active research projects in this area. A great example of that is the Penobscot Narrows Bridge in Prospect, Maine. This bridge has been in place for a number of years, but it provided a wonderful opportunity for monitoring because it contains 3 carbon fiber composite cable strands within it. Professor Roberto Lopez Anido at the University of Maine has been monitoring this bridge and assessing its behavior, in particular how those carbon fiber composite cable strands are performing under thermal and mechanical effects for quite some time, and he's got some really interesting results from that. Professor Lopez Anido has also been leading some really interesting research in 3D printing and automated manufacturing for the creation of concrete formwork. One area that he's done this in is the creation of formwork for railroad ballast retainers. And that printing technology allows molds, forms, and tooling to be made with far lower labor costs, almost none. And we can really optimize the design of precast concrete parts because the additive manufacturing cost for making a complex form is really small. It's just a function of how much thermoplastic material you need. It doesn't depend on part complexity. So instead of having some really complicated carpentry and a lot of labor costs, you can print a complicated thing and then you can pour a really complex part. And also those 3D printed molds are an asset when they're done. They're not something you just throw away, but thermoplastic composite materials can be reprocessed. They can, in a nutshell, be melted, pelletized, and then used to make other thermoplastic items after they've been used. Building on this, Roberto has recently moved into the area of culvert rehabilitation, in particular installing diffusers in culverts. And these diffusers have a very complex geometry, and they essentially allow you to increase the flow through the culvert through a Venturi effect. And the problem is, the challenge there is the geometry is very complex. And to manufacture this out of a composite material in a conventional way through, say, a vacuum bag infusion process would be very expensive and labor intensive. But we can 3D print these complex shapes relatively quickly in an automated way. And this allows a cost-effective solution to be deployed that has some real performance advantages. Another topic that has high relevance to what you're going to hear about today is the prevention of stress-induced failures for precast concrete ties and railroad track structures. This work is being led by Dr. Mushul Shin at Western New England University in Springfield, Massachusetts, and he's been looking at different ways that we can look at stresses in concrete railroad ties, different types of pre-stressing wires, and how they affect performance. And this is a great project. He involves a lot of undergraduate students as well as graduate students into his work. He's looking at different types of concretes and mixed designs in conjunction with different types of pre-stressing wires. And he's really looking at ways of optimizing these railroad ties and making some nice advances there. Research Thrust Area 4 is focused on connectivity for enhanced asset and performance management. We've got 4 active research projects ongoing right now at Maine, UConn, and UVM. Connected vehicle applications for improving infrastructure safety and durability at Maine, as well as safety assessment of New England roadways during COVID-19. At UConn, they're actively involved in proactive and intelligent risk management and complex civil infrastructure project systems. And at UVM, the development and application of a cost-benefit tool for quantifying external social impacts of small to mid-sized transportation projects. At this point, I'd like to thank our conference planning committee before we move on. Jim Bryce is the TIDC Senior Program Manager. His leadership is vitally important to the success of this as well as everything else we do. Dale Peabody, whom I've mentioned earlier, he's the Director of Transportation Research at Maine DOT. He's been very involved in putting this conference together. Ramesh Malla is the institutional lead at UConn, professor in civil and environmental engineering. You'll be hearing from Ramesh later today. He's very involved in railroad-related research. Mushul Shin, Western New England University. And we've got some staff members that do a great job. Amanda Collimore, Education and Outreach, Aaron Skank, our Communications Specialist, and Jenna O'Barron, our Administrative Specialist at the TIDC. They really keep the wheels greased and keep these things going. At this point, I'd like to introduce our keynote speaker. It's really a great pleasure. David Fink. He's a fifth-generation railroader. He began his career at the age of 15 working on the Conrail track gang in New Haven, Connecticut. Not many people can claim that today. He chose to study transportation logistics, received his bachelor's degree in transportation from Northeastern. He followed up with a co-op at the Boston and Maine Railroad, so we've got a Maine connection there. Continued his education at Penn State University, getting a master's degree in business logistics, and following graduate education, he worked at General Motors Corporation in Detroit, as well as assembly plants in Kansas City and Van Nuys, California. In the late 1980s, he became the president of Permatreat Corporation, a treated wood products firm in Durham, Connecticut. He led the startup of the Heuristic and Bangor Resources, a lumber products firm and a co-generator of electricity using railroad ties based in Mattawamkeag, Maine. About 10 years later, in 1998, he joined Pan Am Railways, New England's largest freight railroad, as the executive vice president. In 2006, he was elected president. A bit later in 2011, he held the position of president of Pan Am Systems. Pan Am Systems was merged with CSX Transportation in June of 2022, and he is now president of Pan Am Group LLC, a holding company which includes Forest Products Company, a licensing group, and an airline charter service. In 2020, David joined the faculty as an adjunct professor at his alma mater, Northeastern University, where he teaches supply chain management at the DeMore McKim School of Business. So, again, thank you all for attending, and at this point I will turn it over to David, and we're all looking forward to his keynote presentation.